Intro: you've been lied to about black holes. Scientists told us they were invisible, silent, undetectable, that we could never witness what happens when two of them collide. They were wrong. In 2015, humanity heard the universe scream. Two black holes, each heavier than 30 suns, crashed into each other at half the speed of light. The explosion released more energy in 1 second than every star in the observable universe produces. In that same second, combined, and we felt it here on Earth, 1.3 billion years later. Today we explore what really happens when two black holes collide. What you are about to learn will change the way you see the universe forever. Part 1. What is a black hole? Before we talk about the collision, we need to understand what black holes actually are. A black hole is not a hole. It is an object, the most dense object in the universe. When a massive star dies, it collapses under its own gravity, compressing all its mass into an infinitely small point, called a singularity. Around this singularity, gravity is so powerful that not even light can escape. The boundary where light cannot escape is called the event horizon. Cross it, and you can never return. Not matter, not light, not information, nothing. Black holes are the universe's point of no return, and when two of them find each other, the result is beyond anything the human mind can imagine. Part 2. How do two black holes find each other? Black holes are invisible. They emit no light. They cannot be seen directly. So how do two black holes find each other across the vast emptiness of space? It starts with two massive stars orbiting each other, a binary star system. When both stars die, they both become black holes, still orbiting each other, now as two invisible monsters, circling each other in the darkness. Over millions of years, they spiral closer and closer, losing energy as gravitational waves, tiny ripples in the fabric of space-time, getting closer, faster, closer, faster, until finally they are orbiting each other in hundreds of times per second, the fabric of space itself, twisting and warping around them. And then they merge. Part 3. The final moments. The final moments before collision are the most violent in the universe. The two black holes are moving at a significant fraction of the speed of light, orbiting each other so fast that space and time themselves are being twisted like a cosmic washing machine. As they get closer, they speed up. As they speed up, they get closer, a runaway spiral, and that ends in only one way, in the final milliseconds. The gravitational waves they produce are so powerful that they carry away more energy than the sun will produce in its entire 10 billion year lifetime, in milliseconds. Part 4. The collision. When they finally touch, they do not explode like a bomb. There is no fire, no sound, no light, because nothing can escape a black hole, not even the energy of the collision. Instead, the two event horizons merge. The two singularities become one, and in a fraction of a second, a new black hole is born, larger, more massive, more powerful than either of the two that created it. But 3 solar masses of material are converted directly into pure energy. Gravitational wave energy, released in a fraction of a second. More energy than all stars in the universe produce in that moment, combined. Part 5. Gravitational waves. Something does escape the collision. Gravitational waves, ripples in the fabric of space-time itself, spreading outward at the speed of light, in all directions. Through everything, these waves pass through planets, through stars, through galaxies, through you right now, and as you watch this video, gravitational waves from ancient collisions are passing through your body, and at this very moment, you cannot feel them. They stretch and squeeze space by less than the width of a single proton, but they are real. And in 2015, scientists built a machine sensitive enough to detect them, called LIGO, the Laser Interferometer Gravitational Wave Observatory. Part 6. The discovery that changed everything. On September 14, 2015, at 5:51 in the morning, LIGO detected something extraordinary, a gravitational wave signal, lasting just 0.2 seconds. Scientists analyzed it and reconstructed what had happened. 1.3 billion years ago, two black holes, 136, times the mass of our sun, 129, times the mass of our sun collided. The merger created a black hole, 62 times the mass of our sun. But 36 plus 29 equals 65, not 62. 3 solar masses were converted directly into energy, released in a fraction of a second, Einstein predicted gravitational waves in 1916. It took humanity 99 years to prove he was right. The scientists who built LIGO won the Nobel Prize in Physics in 2017. Part 7. A new way to see the universe before 2015. We could only see the universe using light. Radio waves, X-rays, now we can hear it. Gravitational waves are the sound of the universe, the rumble of colliding black holes, the chirp of merging neutron stars. Sounds that have been traveling through space for billions of years, that we are only now learning to listen to. Since 2015, scientists have detected dozens of black hole mergers, each one telling us something new about the universe we live in, and this is just the beginning. Next generation detectors will be 1,000 times more sensitive, able to detect black hole collisions anywhere in the observable universe. We are learning to listen to the universe's deepest secrets. One collision at a time, outrode two invisible monsters found each other across the darkness of space, spiraled together over millions of years, merged in a fraction of a second, and sent a ripple through the fabric of reality that traveled 1.3 billion years to reach a tiny detector on a small planet, orbiting an unremarkable star. And we heard it. For the first time in human history, we heard the universe speak. What do you think is still out there, waiting to be discovered? Comment below and we read every single one. If this video blew your mind, hit the like button. Subscribe to Cosmic Truths for mind-blowing space facts every week. See you in the next one. But here is what makes this discovery truly extraordinary. For the first time in human history, we did not just observe the universe. We listened to it. Every civilization before us had looked up at the same night sky. The ancient Greeks, the Egyptians, the Mayans, they saw the same stars, the same galaxies, the same darkness, but none of them could hear what was happening. The collisions, the mergers, the explosions, all happening in silence because we had no ears sensitive enough. Until 2015, think about what LIGO actually is. 2 tunnels, each 4 kilometers long, built in an L shape. A laser beam split in 2, sent down each tunnel, and reflected back. When a gravitational wave passes, it stretches one tunnel slightly and squeezes the other by less than 1,000th, the width of a single proton, and LIGO detects that. The most sensitive instrument ever built by human hands. It took 40 years to build, thousands of scientists, billions of dollars, all to detect a signal that lasted 0.2 seconds and changed everything. Since that first detection, scientists have heard dozens more. Black holes merging, neutron stars colliding, each signal a message from the violent past of our universe, each one teaching us something new, and the next generation of detectors is already being planned. LISA, the Laser Interferometer Space Antenna, will be launched into space, with arms 2.5 million kilometers long, 1 million times larger than LIGO, sensitive enough to detect black hole mergers anywhere in the observable universe. We are just beginning to listen. The universe has been speaking for 13.8 billion years, and we have only just learned to hear it.